Recording.
Yes.
Yeah, go ahead.
Yeah. So that is the one we discussed on Sunday. Okay. Let's. So our first problem here is super egg drop. So we are given here kx, and we have access to a building with n floors, which are numbered from 1 to n. Now each of the egg is identical in function, and if an egg breaks, we cannot drop it again. Okay, I mean it will be discarded, and we know that we have a floor f where the f will lie from 0 to n, such that any egg which is dropped at floor higher than the f will break, and any egg dropped at or below will not break. So each move, we can take an egg and drop it from any floor x, where you can say that x will lie between your 1 to n, and our goal is to know with certainty what value of f will. So it is the minimum number of moves that we need to know with certainty that what f is regardless of initial value of f. Okay. Yeah. So if we look at this example, right? So here k is egg is one and floor is two, right?
Right, right.
So yeah, if we break it, I mean throw it from the first floor, if it breaks, then one it will be. Will go down. Otherwise, we'll always here like we'll always check for the worst case, right?
Yeah,
I mean
because
if
we
it
have a
doesn't break,
single egg, right? So we have to
exactly.
go from the first floor. Yeah.
Yeah, first to second. So two moves total here.
Yeah. So whenever egg is one and we have
Hmm.
any number of floors, so we have to start from the first floor and just keep on
Yeah,
dropping to the end. So that it
yeah.
will always be, it will always return the value of n, right? In this
And
case. So it's a
yeah,
base case. Yeah.
base case kind of.
Right. Right.
And next, like we have two. Sorry, what is happening? Okay, we have two eggs and floor is six, right?
Mm-hmm.
So like, I mean, what do you say? Three. I mean, in that case, like from two first, we'll take one egg. We'll try to drop it from first floor, right?
Mm-hmm.
And again, if it doesn't break, then we have two choices, right? If the egg doesn't breaks, then two, and we'll increase the whatever current floor is a total floor minus k will do that, right? And in case if it breaks, then the number of this will reduce, and we will what do you say, we'll go for the lower floor. I
Yeah.
mean
So
minus change.
yeah. So K, okay, so K
Current
is,
floor.
if the K is egg, so in that case we, yeah,
This is
that
I.
will be some, yeah, so you can say like I, okay, yeah, that is good.
Yeah, this is a current floor here.
Right. So, so we start with a single egg, because
Mhm.
we have two eggs, and then we drop them from any floor. So when we drop them from say floor I, right? So then
Yeah,
we have two options, either it will break or not break. So if it breaks, it means we have one egg lesser. So the one what you are showing here at the bottom one, one, right?
yeah, one minus.
And yeah, so it is breaking at the current floor, ith floor, right? So this one
Yeah,
you're talking. So when it is breaking at ith floor, so you will actually also reduce one more floor and you'll go down one floor. So therefore it will be I minus one, this one.
yeah,
So
mhm,
this will be one sub problem, right?
yeah,
And the other sub problem will be like if the egg doesn't break, so it means you have all the eggs, but you still have to cover the n floor minus I, n minus I floors, right?
yeah.
So that is what your second sub problem is.
Is yeah. So if you break at this floor, like if the egg didn't break at k floor, so remaining this much space will again explode, right? With
Right,
those
right.
many.
Yeah.
So this is like a optimal strategy, right? The min max game what we are doing there also. Like you, when you play, you give the best of your scores, right? But when the others play, you take the worst of it.
Mm. Yeah, maybe related. I'm not able to recollect that problem though. Yeah, but
Uh,
yeah, you'll have a lot of patterns, similar pattern, right? But there
yeah,
will always be some
minor
slight
difference.
difference between each of them, right? So based on the problem, you will have to be very careful about all the optimal substructures, right?
In that case, yeah.
So yeah, yeah, but the whole problem is like this. What you are saying here, we have always two sub problems.
Yeah.
So from when whatever floor we drop a egg, okay, so we have only two sub problems. One is you go below or you go above, right?
Two places, yeah.
Yeah, and then when we are left with only one egg, so you start dropping from each and every floor from the first one all the way to the top,
Top, yeah.
right? So other than that, there is nothing much in this problem. So if we actually try to solve this problem this way, like the top-down approach, exactly by breaking the problem into two sub-problems, and then just take care of the base case, then we are good, and we have
Yeah.
to just memorize it, so that it becomes a very simple problem, right? At least the
Mhm.
top-down.
Mhm. So in base case, if you have 0x, then there is nothing to do, right? Everything is zero. I mean, it's a null case.
So if it is zero, yeah, then it is going to be nothing. So
Nothing, yeah.
yeah, so if you have zero eggs, then no tries, right? So you won't be able to try anything
Anything,
because
yeah.
yeah. So the output is we are going to return the number of optimum tries, right? That is what the output should be. So if you don't have any eggs, you can't do anything. So that therefore it will always be zero. And also if you have x zero, so all of these floors will also be zero anywhere. So yeah, the base case is always going to be zero in that case too. Yeah.
So it's like, I mean, if let's say if we have three floors, zero, one, I mean, two floor only, let's consider, and I mean, two x and one, sorry, zero, one, two, three, three such floors. So this case will be, these are x, right? And this is floor. So this will be nothing, right? Zero x. So we won't consider anything.
Yeah. Also
And
for eggs also, like if you have any number of eggs and the floor is zero, so you can't do anything.
yeah, this one is
So
also
that
zero.
also will be zero. Yeah.
Yeah. And if you have one egg, so whatever the number of eggs is, if you have only one floor, then only one you will have.
Yeah, so
Would be
that
so.
also comes under base case. Like if you have only one floor and if you have n number of eggs, so the eggs are not zero. So if you even have more than one or more than one egg, so it will always be one in that case. Yeah. So it will be only
Yeah.
one try, right? Yeah. Yeah. Then you start with two. So in that's two. So now wherever you are marked
So
this,
this is also two, three, right? Because one egg only you have. So you will have full floor will be two, and if three floor it will be three, right? This is also
so
base case.
that is not really a best case because if you see, so if this x what you're marking, actually the value is always zero, right? So
Yeah,
what you're
those
trying to do, yeah. So to actually get the values over here, oh, I'm sorry, yeah. So for the first one, you are saying this x,
first
right?
one.
Yeah.
Yeah,
So they are going to be one, two, three, based on whatever the floor
number
are.
is.
Yeah, right, right. So that is correct.
And coming to this, max of these two, and max of these two, and whatever the mean is, that will take.
Right. Yeah.
Yeah. So this will be two then.
Hmm. And then same thing you do for the three. So in that case, now you start with the extreme 0 and 2, and then you keep on incrementing that, right? Yeah.
Yeah. This we compare, and then this, and this, and this.
Okay, yeah. So then you will have to find
Zero
the
and zero two will be two, and then one will be one, and two zero will be two, and min of this will be one, and plus one will be, so it will be two.
correct. Yeah. So that's the way you'll have to. So on and so forth. If you do, so you will get the bottom up also, right?
Bottom, yeah,
Yeah.
yeah. Only I think base case is little bit like extra care we are taking. If floor is single, then whatever. Sorry, egg is single. Whatever your number of floors is, you just push it as an answer.
Right. So the base case here is very easy to find out, right? In this the egg dropping
Yeah.
problem. Yeah.
Yeah.
As well as the one, and then we are good. So that is what the bottom up is also. But in this case, in the lead code, they don't accept these normal problems. They are actually TLE because of the test cases, right?
Yeah.
So, but I would still say whatever we discussed, if we are able to implement accordingly, so that should be okay for an interview person, right? That should
Yeah.
not be a problem. But they are trying to say that we can do slightly more better, and that's the reason they want us to push
In
towards
that
the
case.
binary search.
Yeah.
Yeah, even if we look at the nodes, okay, the K and N, they are just 1000,
1,000 into 100, right?
10,000 into 100. So,
10,000 into 100. So it should pass. Why it is not passing? 10 raised to power 8 is allowed, right? But it was giving TLE. Yeah, that's true.
yeah, so if you have that already implemented and you try in Python, at least the C++ was giving a TLE, you can try that. But yeah, it was TLE for the C++ implementation.
Yeah.
So only the binary search actually works.
In
So
that
so
case.
did you try that? If
I
you
think,
have
yeah,
that
I have
handy,
tried.
can you just
Yeah, this is giving TLE, I think.
so what is that bigger number? The one which yeah,
Uh,
that implementation. I don't think so. That should be a binary search because binary search doesn't give that bad numbers, right?
this one you are saying, the one.
Yeah, even 1380 should not be that bad for a binary search. It'll be much better.
I use bottom up only here also. It passed. I mean, the
Okay.
different kind of bottom up here.
Okay. So you're not doing the binary search, right?
No binary
Yeah.
search.
So then that makes sense. The 1380. Yeah.
Yeah, only four of them were okay. For the last 63 passed only.
Yeah. Only half of them passed.
Passed, yeah.
Yeah. So the binary search actually works fine.
Oh, completely, yeah.
Yeah. So this 1380, whatever you are getting for the other two, they should be also the same implementation. But
Or no.
sometimes, yeah, sometimes in this, I've seen in Leetcode what happens if you are at the very corner case. Well, sometimes it gives TLE and sometimes it gets accepted, right? If
Passing.
the numbers are
Yeah.
too high at the runtime, yeah. So,
So in interview we can use this, right?
yeah, absolutely, why not?
Yeah.
Because that is what the problem statement was as well as the implementation. Everyone knows about this problem statement as well as the
April.
implementation, right? It's
Yeah.
very standard now. But the only thing we'll have to explain it exactly the way we are just discussing, or maybe we can give better explanation because people have different ways to think about it and they have solved it n number of ways, and nothing is wrong in that also, right?
Yeah.
But these are the base ones implementations, very the basic ones. But people have come with more enhanced versions of these things, and so
Yeah.
if we are able to get to that, well and good. But if not, but these are also fine.
Worst case, yeah.
Not worst case. These are the way actually it has to be solved, right? Yeah. But people have come with innovative ideas, and I really like that. But if you
It's like
understand
a
and uh-huh.
morning knapsack problem, two knapsack, right? Problem are same, but the constraints are different.
Yeah, so it is like yeah, but that is a different case because they are trying to add in more test cases there. Okay, so the
Yeah.
problem is completely same. But if you have more test cases, then you will try to optimize in a very innovative way. You cannot optimize the normal way, right? So you'll
Exactly.
have to like in this case, if you really want to attain a 0 millisecond from 1380 milliseconds to zero, so you cannot go by these things and keep on optimizing small constraints like the numbers or maybe the memory size and all that. You'll have to think very completely different, a paradigm shift of thinking, right? So like a
Everything.
mathematical approach. That is what they have said also in the solution, right?
Yeah, we have one
Something very
math.
different, yeah.
Yeah.
Yeah. So this is a very interesting problem.
Yeah, only. But
No, it is because if you look at the discussions, there are so many ways people have solved it, and it's insane. You can say that. Yeah,
the binary search here, there
yeah.
are.
That
Math
that is
solve.
binary search also.
Maths one, do you have like what?
Sorry, what was that?
The maths one you told no, using maths that I didn't see. I haven't seen also there.
It is in the solution.
Okay,
So
okay.
it is the very first problem in the solution. So, but yeah, I didn't understand that. That is what happens if we go in the depth of that and try to see how people are solving this, and everyone has their own way of implementing it, right? So
Yeah,
you'll
yeah.
have to understand his mindset to understand the problem. So, or
Again,
maybe if he has not written all the, so in the solution, at least they have mentioned everything very well, right? So you can understand it. But people, when they put that in the discussion, they really don't understand, or they really don't describe where they're coming from. So it's sometimes very difficult to understand. Some of them do, but not all of them. So you'll have to go from the code to reverse engineering and understand it. So that becomes sometimes more tedious, right?
yeah, this is a little bit.
Yeah, this
That's
one,
what
right?
I
The stable.
think.
So the way is coming. So it exactly boils down to this problem. So it's like the first row, whatever it says, 1, 2, 3, 4, 5, 6, 7, it's a single egg, and then we keep on using those two egg, that base case, and keep on growing on that. So some sort of the Fibonacci series, what we do, something like that, a pattern like that. I'm not saying that way, that approach. So he's just building on the for the first base case of egg one. So he's building all the other egg layers, right?
Yeah, that, yeah. So he's going diagonal. Okay, diagonal is taking plus
I'm not sure how it is being done, but
t
if you look at
minus
the
one, t
formula
minus.
exactly the way he is doing it, but why is coming with those things?
Mm. Yeah, we'll look later
I
into
didn't
that.
get a chance to look at
Yeah,
it, but it seems very interesting. Yeah,
we'll check it in some other section. Then.
sure. Yeah,
Yeah. So this is okay. So this is like normal, like what we did on Sunday also. I'm
right,
creating
right.
a
Yeah,
layer n cross what do you say floor cross x. I'm creating a DP filling within infinity. Now these
correct.
are the base cases that I'm doing with 0x with 1 egg.
Uh-huh.
So with 0 egg, like everything will be 0 only because it's a null. And if you have 1 egg, then it will be 1, right?
Mm-hmm.
Yeah.
So
And
that's the
this
base case, right?
base case, yeah. This is again one base case for the number of, I mean, what do you say? For the number of the floors. I mean, if your floor is 1,
No,
so
this is
whatever,
for if you have an egg one, right? If you have one egg,
okay, k is first is row. Okay, yeah, you have 1 egg, then whatever the floor is, it will keep on increasing
yeah,
depending on that.
right,
Yeah,
right,
yeah, I got it.
right.
And this is the filling from that what you say what we did just now in the bottom of like
Exactly.
as long as k is less than this and whichever is greater maximum of them, and then we increase the k and whatever result we are get after taking the maximum we take the minimum of it and add plus one and substitute it there.
Right, right.
Yeah,
And the
yeah,
way you were doing it in that the
diagram.
table, yeah. So
Yeah,
if you observe that the first row, which was yeah,
yeah,
so it was going the ascending way, and the other was going the descending way, right?
yeah, we are one from this side other from this side and we are comparing these two, right, for this one.
Oh yeah, both were same, right? Okay, yeah. Hmm.
Yeah. And then again it will come here and this will come here, and again whatever the max of this, so max of this and max of this and min of them we are taking.
Yeah. So when we were, so one of them we go in from the left to right, and other we go from the right to left,
Yeah.
right? So when both of these meet at the center, okay,
Oh mid, yeah.
yeah. So that is the point actually will be the most minimum
Mid.
point,
Mhm.
right?
That is what
So
it's big on line number 14.
Yeah, but actually, so that advantage we are not taking in the bottom up approach also, right? So that
Yeah,
advantage they are taking in the binary search, you know. So what happens, why this is more slower than the binary search? Because the way you just showed in this table,
yeah,
right? So we
yeah.
go all the way from left to right, okay. At the same time we compare going from the sorry, left to right, I'm writing it different.
Yeah,
So yeah, so we do it this thing and this. We try to compare each and every point. But in binary search, what it does, okay, it just takes the left and right. So maybe that is right and this is left. Okay, it finds the minimum, sorry, the midpoint, and then whenever the midpoint, if it comes here, in this case, if it lies on this cell, you know, so at this you will find the most optimum solution.
minimum.
Okay,
Okay.
yeah. So when you find the most optimal solution, you just break from that, because what is the optimum solution? When your the when we break into two sub problems, right? One is the egg breaks and one is the egg doesn't break. So at that time, if we have the values of both of these two sub problems, whatever they return, it is same. Okay,
Yeah,
when it is same, so that is the most optimum solution. So binary search uses that advantage, and he breaks quickly out of the loop. Also, like he is actually in binary search, we are actually dividing the sub problem again in two. So that is another log n saving, correct?
search space reducing. Yeah.
Yeah. So therefore, binary search is more optimum than the top down or the bottom up approach. Okay. So
So
just
yeah,
just just because of this, if you just observe it the way we actually do it for the bottom up, and then we try to, because we, even if we find the most optimum here, we still go ahead in our in this top down approach to the very end, right?
to
So we
check.
don't
Yeah,
stop. If you look at the while loop on line 14, whatever you're doing, 13 and 14, you keep on going. Okay. So that is the different advantage what the binary search takes.
searching. Yeah.
Yeah.
So, do you have that for binary search code? Like,
Yeah, I'll just, no problem, I'll just share it.
yeah, yeah.
Okay, just give me a minute. Okay, so this was the binary search, right? So uh, well, everything remains same. I'm using a top down approach here. So when
Yeah.
we come back in this helper function, this k is the same, the number of eggs, and n is the number of floors. Okay, and this is our memo. Okay, so these are the base case. Like if our floor is 0 and floor is 1, you return n, and if k is 1, you return n. So this is the memoization part. And here we start, like if it's minimum, so this is my left cell number 1, and then floor number actually 1, and the right floor number which is n, and then do a binary search on that left and right. Okay, so when I
Yeah.
find a midpoint, okay, so now what I'm doing is I'm just going taking this midpoint, okay, and then breaking it into two sub problems, assuming that my cell is breaking or not breaking. Okay,
Yeah.
so when I just do that, and then whatever the value I get, okay, so these two values I'm just comparing and doing exactly the way we are doing for those top down and bottom up approach. But the only different thing is we do it like we actually divide that. That is one thing. Also here, if we look at this problem, sorry, this statement, when your T1 and T2, whatever your output of these two sub problems is same, you just break from here, right?
Most minimum point that is.
Yeah, because it doesn't make sense to go ahead, because you have got the most optimum, it, so why you want to go ahead?
Mhm.
So that is one optimization. And second is about, we again go, if our search space is not correct, okay, we found a very incorrect search space, we again take the advantage of the binary search, right? So if
That
it is
is
lesser, then we move our right side. Okay, if the T1 is lesser than T2, we move our left side. uh, or else we move the right side. That is a normally binary search, normal binary search. But only this condition is slightly different. Okay, so we take advantage of both of things, and therefore this is a more optimum solution.
Exactly.
So yeah, even if you don't come, if you are unable to come this implementation, it's still good, right? So we can still go with the top down and bottom up approach what you discussed. That should be still
Yep.
be fine. But in worst case, if someone asks and if you are able to get this, it's well and good. But if we can't go to the mathematics solution, I think that is still okay, right? The math solutions are slightly different altogether. But for our implementation, this is the best solution if you can go to this.
The binary one. Yeah.
Yeah. So you'll get more additional points in that. There's only one advantage here. But I'm saying it's not necessary as per me. So the top
Yeah.
down and bottom approach are also the most standard approaches, right? It's
Yeah.
been
Most of the places we have the same. I mean, the bottom
right.
up and mhm.
Exactly. Yeah. Yeah.
Yeah. We can move to next.
Right. Yeah.
Can we solve this problem just using the binary search, not the DP? I'm thinking to use the whatever we call it, the expanding binary search.
Oh, yeah. Maybe that is possible.
So like start with the first floor, then second, then fourth, then eighth.
Hmm.
Okay.
Hmm.
Mm.
I think that should be possible. Why not? We can use the same way, the way we are doing binary search, and there
Mhm.
also we can actually look for the two sub problems when they meet. You know, then we can break early in that case. Yeah, I think that should be fine. Absolutely. If this normally binary search works, I have never tried it, but I'm just thinking loud. I think that should also work.
Okay. Yeah.
Or directly mid also you can check. It won't. I mean, drop from the mid only. If it breaks, that
That
means
is
it.
what we do for the binary search, exactly what
Yeah.
you're saying. That's exactly being done there. If you really go through that implementation, they do it
Yeah.
exactly the way what you're saying. You just check for the mid, and if it is not breaking from the mid, then you just move around your right hand
No,
reserve space.
that,
Downside.
that will not work. I mean, you will not get the optimized solution with that. Because if it break in the mid and you have only two egg, then you for the next one you will have to start from the first one linearly.
Well, then you change your search space, right?
No, but if you have only two egg and you just go and check the mid first, right? And let's say it's break. So now you left with only one egg. So you have only one choice. You go from the ground and check linearly, right?
Yeah,
But
but
if
that
you
is
go with the expanded, so you are narrowing down the scope where you will have to scan the linearly.
well. So okay. So even if the binary search, okay, so we actually randomly take some mid floor, right? We divide that into right, left, and right. We find a midpoint, and if it's not working, then you have to change the midpoint, no? So that is what we are doing, right?
No,
So
but
I
he's saying
understand what.
that
Mhm. But then,
if it breaks at the mid, then what do you say? What you'll then he is saying that we are left with only one egg, right? And our search space is from one to mid
but actually, we are trying to find the number of tries, right? So the eggs are
minimum.
breaking fine, okay, but we still then we move our search space, no? So we
Yeah,
are
we'll
trying to
move it
find the
down.
number
We'll
of,
move.
yeah. So if it break, that's fine. That's so we actually discard the whole thing again. Then we move to the different search space. Then we are starting again from fresh. No, that is what binary search we are doing. We are trying to optimize on the tries.
No, but let's say
But your
first time
count
it
will
broke
get
at the mid,
increased. Your
and
your
now
space will get increased now.
Yeah. So if you go to the mid, right? So
hmm,
this is not the case like when we break the egg or what we do if we are left with only one egg. What we are trying to do is we are trying to find the number of tries.
Minimum they have
Yeah,
asked,
we are
right?
not trying to find the floor or anything. We're trying to find the number of tries what we are doing. So in this case, if we fail, okay, from this mid also we say, okay, it is breaking. Okay. Okay, then we
Yeah.
have two sub problems here. That's fine. But then it is not working. So we need to find a different floor. So you change the midpoint. How you change the midpoint? You either move your left pointer or the right pointer. Correct.
So now your next mid will be between these two, right?
Yeah, so that is the way the binary search will do.
Yeah. But let's say you found the mid, and again the second egg also got broken here, right? Then,
So then you go to this space, right? Then
but
you
you are
go to
not
the
left with egg then.
As soon as your egg breaks, so which means that you use one step
Yeah.
to reach to your target.
yeah, that is fine. But we don't stop there. We have to change our
Yeah,
search
so
space, right?
that's what I'm saying. That this way you will not get the minimum number of steps.
No,
Because
that is fine. So the way you are saying the index binary search, there we might be getting. I'm not saying, but this way also we'll get. Therefore, it is the binary search is working, right? Oh,
no, but second, let's say second mid is this, and here you got the second egg, and that also the egg got broken. Now you are left with no egg, but still there is one floor in the answer from here, which I mean from here you can break, but you are not left with any egg then.
well, see, when your egg is breaking on this mid, so it means this mid is not correct, right? So we have to find a different mid.
Yeah, but
Yeah,
you
so
are exhausted with both
yeah, so
eggs.
that will increase your step, right?
Yeah, yeah,
Hmm.
yeah. I'm saying that. I'm not saying that about that. So if you're saying your index binary search might be much better after, that's fine. But I'm trying to explain because Shashank is asking a different question, right? So
Yeah,
it's not
I'm
the
saying that
question of finding the floor here.
you have two eggs. Like first mid you took, and here it broke. Now you are left with one egg, right? Now second mid you found at this place, and this also got broken. But real answer is lying at this. What do you say? This floor, critical. I mean,
Yeah. So when you
so
come with like this, when you come up with this saying, okay, your two eggs. So
yeah.
then your problem, you are actually restricting yourself only to these egg numbers. So the question is not about the egg numbers.
Oh,
The question is about the tries. So there can be two, they can be anything.
yeah. Anything. Yeah.
So you always consider the generic case, that is K, right? So
Yeah.
what we are trying to find the point, the midpoint is actually the point which is the most optimum point. So unless and until we don't find it, we are just doing the binary search. We are just moving the midpoint till we don't find that particular number of tries which is optimum. And in
Nice.
that, they are taking the help of that what I was talking about. If we have two sub problems, and if we get whatever the value from those two, the number of tries, if they both are same, then we break early. So that is one thing. Okay, but the way that is a binary search, but the way Praveen is coming up with the index binary search, it might be more optimum to use that.
The index,
Yeah.
increasing by
So
number of. Yeah.
I never tried that, but that might be possibility also. So that's a good thing to try, right?
Yeah. We can have that. I mean, he's expanding with a factor of 2 every time if it
Right.
doesn't find. Yeah.
Is that correct? Or thought process, Praveen?
Yeah, yeah, yes.
Okay.
So every time, I mean, whenever the egg will break, so we are actually narrowing down the scope where we actually linearly check that from the previous correct state where egg was not broken. So we will start the linearly from there, that point.
Hmm. Okay,
Yeah.
it will be good to try and see how it works in Leetcode because that solution also will be get accepted, right? So we can
I
just
Right.
will
compare
try,
the.
and if it works, I will post the solution.
Yeah, yeah, that would be great. Yeah, yeah, no problem.
Thank you.
Yeah, thank you. Yeah,
So then we can move to next.
yes.
So next is like what do you say? Minimum falling path sum. So we are given a square of integers, and we have to find the minimum sum of a falling path through A. Okay, and it's defined like it. I mean, falling path is defined. It starts at any element in the first row and chooses one element from each row. Okay, and the next row's choice must be in a column that is different from previous row column by at most one. Yeah.
Is this problem not exactly the one what we were
Yes.
discussing yesterday?
Yeah, yeah, yeah. Frog one, right? Yeah. Not frog, sorry.
Not
The
frog.
matrix one.
The matrix one.
The
But
top
there is
coder one.
slight difference, I think.
Little bit different is that, but I also thought same almost.
Mhm. But when I was actually trying this, it was not so easy for me. It
Yeah,
looks
definitely.
very easy when I follow this explanation, correct? But if you
Yeah.
try to implement it and if you try to think for a generic test case, then it becomes more challenging.
So here I think we'll have to a little bit difference. I don't think so much difference we have, right? Earlier we are having like if we choose this option, then we are not supposed to take this activity, right? These two will be the options for us. But here they are telling a polling part starts at any element. Choose one element from each row. The next row's choice must be in a column that is different from previous by one. So if we take this one, right? So what would be our next choice then?
Okay, in this case, it's slightly different. The way he's saying is
Hmm.
you can, when he says the column by one, okay, the previous row column at most one, it means when you are taking one, okay, let me
Yeah.
annotate, yeah. Okay, so if I'm taking this one, so when you come to the next row, okay, you can take this guy and only these two.
Yeah.
Okay, so that is what it's trying to say. And
Hmm.
then if you come for the this case, in this case, right? So you can take this guy,
Coincidence.
and this guy.
Yeah.
So they are actually one distance apart from all of them, right? So this is zero distance, and this is one plus minus, and this is one plus, right? So this is one plus, and this is one minus. So when you are at center, you can take all the three. So this is slightly different than the yesterday's problem. Yeah, but then if
Yeah.
you think that way, if you just modify that implementation, then it's almost the same, right?
Reconciliation. Yeah.
Hmm.
And yeah. So again, we'll have to explore all the branches, right? And then depending on that, we'll take the minimum.
Yeah, we have to explore, or else then we won't be able to find the minimum, right?
Minimum. Yeah.
Yeah, so we'll have to start from each and every column on the first row, and then follow this the rule what we just discussed. Go all the way to the bottom row, and so for if we start from one, in this case, we'll follow all the paths, right? So we'll just follow this path, right? Then it will be this path and this path. So all of them. And if it is a bigger size of this matrix, then there will be many paths to follow.
In that case. Yeah.
Yeah. So because if you might find something optimum here, but still you have to explore this path also from the two, correct? And then also you do from the three. And so when you're doing this, you are actually doing too much of exploration. Okay.
Repeated results will be there. Yeah.
Right. So then that is the reason we won't be able to do this. Maybe this I'm just saying thinking loud, using a greedy or so. So we might have to use a DP in that case, right? Or
Yeah.
am
No,
I
no.
not correct in that?
Greedy won't work, I think. Same reason, like, I mean, we don't have example here for that. Maybe there is.
No, at each step, we have three options to take.
Mm-hmm.
So, from the current column, no, from the current row, we can take three values from the previous row. So, I think the greedy solution will work, but it uh, since the value at a particular row will give us the uh, optimized value until that row. So the value which we get at the last row in the 2D array and the minimum value in the last row of the 2D array will be the final answer.
Okay, so you are actually taking the values from the top floor and then going top row and going to the bottom
Now,
row.
yes,
Okay, and then whatever you are at the end, you store that value and you get the most optimum value from there, right?
yes,
but you still have to explore all the paths now.
Yeah, like,
No,
and
but
it's
Uh,
not that
but
for each
what
of
I
them we
did
have like
is
options. Okay, go ahead. Yeah.
what I did is I calculated the value in place. So I did not use a extra DPRA.
oh, okay,
So
okay.
so
Modify
while
the input
yes,
matrix.
so while traversing through each row, I will not traverse from the first row. I will traverse from the second row. Then in for each values, I have three previous values to add from, and I will take only the minimum of those three values, and I will add it to the current value. And this process will continue until the last row. And in the last row, we are sure that we will get a minimum path, minimum sum path, and we will return the minimum value in the last row after processing all the value.
Hmm.
Okay. Do you want to share? Like, okay.
Yeah.
Yeah, sure.
Okay, so let me take an example. So this is the array 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I will not travel from, I will skip the first row, but I will start traversing from the second row. And then for the value 4, I have two options. Either take the value 1 or take value 2. So I'll take the minimum of these two. So it will be 1. It will be 1. So I'll add 1 in the value 4, so it will become 5. Again for 5, I have three options to add from, which is 1, 2, 3. So I will take the minimum, and the minimum will be 1. So I will add 1 to the value 5, which will be 6. Now for value 6, I have two values to add from, which will be 2 and 3, and I will take the minimum of those two. It will be 2, so after adding, it will be 8. Now this row is processed. I will go to the last row. For value 7, again I have two values to take from, 5 and 6. I will take 5, which is the minimum of 5 and 6. I will add it. It will be 12. Then for value 8, I have three values to choose from, 5, 6 and 8. And 5 is the minimum. So I will add it, 13. Again for 9, I have three values. For 9, I have two values, 6 and 8. 6 is the minimum. I will add 6, so it will be 15. Now the final answer will be the minimum of the last row.
Row.
So the answer will be 12.
Well, yeah, that's good. But is this DP because you are actually caching the values, aren't you?
Yes.
Yeah, it's doing
So it
DP.
is. I'm just thinking, Lord. I'm not saying
Yes.
that's not a greedy or so. But for
Even
me, it looks like you are caching the values. Because you still have to explore, right? But here you are taking the advantage of because we have
Since the
that.
distance should be at most 1, so
Right. Yeah.
I have only three values to take from.
Mm-hmm.
So if I don't do this in place, I have to again make an extra DP array.
Right. Right. Right.
Traversing the DP array, I again have to do this. DP of uh, ij is equal to a of ij plus minimum of minus 1 j minus 1 minus 1 j and minus 1 j plus 1.
Yeah, that will be too much of work. Yeah, that's right. Yeah. Mm-hmm.
So this again is this is what I am doing here,
Mm.
since I have only three options, that is previous, current and next. But for the previous one, we have to check that it might go negative value. So first we need to check, since for the value 5, the previous will be a negative index. So we need to check first if it is negative, then I will take a large value, so it will not count in the while adding it to the final answer.
Oh, okay. Hmm.
And the current will be direct assigned, and the next, even for the next, like for 8, the next will be a value outside the range of m. So again, if it is greater than m, so I will assign a large value uh, which will not be considered while choosing the minimum. So then I will be adding the minimum or all these three. This process will repeat for the excluding the first row, and we know that the final answer will be minimum of the last row. So I return this last minimum of the last. Uh,
Yeah.
it will be 1D array.
Right. Right. The,
Inbuilt caching is doing here.
yeah, but this is a very good implementation. Yeah, it's very out of the box thinking. Yeah, that's
Only
nice.
we are saving this n square space where if we were using DP array, then extra O of n square space will be used.
Right. Right. Yeah.
But if we are using in place, we are assigning the values, then we don't need extra space.
Correct. Yeah. That's perfect. Yeah.
N square only, right?
Uh,
Exploring all
the,
your
the
Yeah.
time complexity will be n square.
Yeah.
In this part is just constant.
That is constant. Correct. Yeah.
optimizing the space.
Hmm.
But I think in interview they'll definitely, I don't know. I mean, if you get the luxury to modify the input metrics, then
Yes, I
that's
think we can start from this DP approach. First, we will declare a DP array of n comma m,
Mhm.
and then for the first row, we will assign the DP values directly, since for this we don't have any value to assign from the previous one.
Previous
But
term.
from the second to the last row, we can start doing this DP approach,
Hmm.
and then
Yeah.
return the minimum value of the last
Yeah.
row.
Right.
And then if the interviewer asks if, to optimize the space complexity, then we can do this in place.
On fly, yeah.
Yeah. Yeah. So, but in that case, also the way the Shashank was saying, if we have to use this array, because if you are not allowed to modify the input array, so
Hmm.
if you are using this DP array, that is fine because it's two dimensional, but we can still use a single dimensional array also, only for the
Mm.
columns,
Yes,
and then we
for
can
the last,
optimize on the space. The way you are
hmm,
doing, almost like that, right? Yeah.
it will be this.
Mm. Something like that. Yeah. That would be one
One
way to do it,
loop
right?
No, I think it
rather,
will be
yeah.
two. We will be needing the previous DP value as well.
Yeah.
Yeah. Maybe we'll need two rows in that case. Yeah. Something like
But
that.
it will be two into n, so
Yeah. Yeah.
it will be n.
Yeah. Something like that. Yeah. That's good. Hmm.
Okay.
Now,
Uh,
the way you implemented it makes to feel like the problem is very easy, but it's not, right?
I think this
Yeah.
type of problem is pretty common in the dynamic programming one. I've solved some problems. The topic is dynamic programming, but
Uh-huh.
uh, similar questions are there with this pattern.
Okay.
Even in some coding tests, I got the same type of problem.
Hmm.
So at first, I couldn't solve it, but the general pattern is same. So next time when I got the same pattern, then I could solve it. Like for example, here we are traversing row wise. Uh, in one of the coding tests, I got like we need to traverse column wise. So
Hmm.
the only these two parts will change. Like here, first we are iterating to the row.
Hmm.
Uh, in that question, we need to iterate only through column.
Hmm.
So,
Interesting. Uh-huh.
Oh, good.
so I think this is a general question. It can be asked in coding this online test,
Uh-huh.
but it will be pretty simple for face-to-face interview.
Yeah.
Oh, cool. Yeah.
Yeah, that's good.
This is why this like to dislike ratio is very high.
Drastic differences. Yeah.
People like it a lot, right? Yeah.
Uh,
But sometimes such problems also are very tricky if you're not able to get it. Now at least we understand the pattern and the way you are explaining, you said it can be uh, change the rows and columns, instead of having the rows, it can be the column wise. So then actually it opens more opportunities to understand in a different way. Yeah.
Yes. So similar question, like we can change the question. Here it is given at most one.
Hmm.
We can do this like if we choose six, then no. If we are at six, we cannot choose from the immediate upper position.
Hmm.
I think I got this question as well. For 12, I cannot choose 5. For 13, I cannot choose 6. For 15, I cannot choose 8. So this current value will be erased. I will be taking only previous and next value from the previous row.
Okay. Uh-huh.
So many problems can be constructed. The general idea will be same for this problem,
Uh-huh.
but it can be enhanced.
Yep, that's good.
Shall we
Interesting.
stop?
Yeah.
Yeah, sure.
Thank you. Yeah.
Yeah, so it's same like what Abhishek explained just now. Like same thing I'm doing for the DP here. Just I'm creating a 2D array with what do you say um, for the n. I mean whatever the dimension of the matrix and
Mm-hmm.
running through what do you say each of the cell of that and
Mm-hmm.
current cell plus I mean one distance element we are taking.
Correct. Yeah. Uh-huh. So you're explicitly using the DPI here, right?
DP
Uh-huh.
array, yeah, and
Okay.
the minimum of what do you say last row and return.
Good. 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 So this is almost like a bottom-up approach that we are doing here, right?
Yeah.
And now it's being a DP, we don't even think of a top-down approach for such problems. Yeah.
Yeah.
So yeah, still the top-down might be applicable. It may be implementable also, but the bottom-up approach seems to be more easier to follow in this
Yeah.
case. Correct?
Yeah.
Yes, for this general question, I think the tabular format will be pretty easy for even uh, visualize, I guess.
Right, right, right. Exactly. When you look at the problem statement, you visualize that way for this one. Correct. So therefore, you never think it might be a DP or so. We just keep on doing it. Right. Okay. Cool.
Top down becomes a bit tricky here, but not
Top
tricky
down
like
becomes, yeah,
I
yeah.
guess we can
equations
declare
will
a
have yeah,
global variable, and
uh,
uh, we can
minimum of.
then we can take the minimum of all the paths.
And what will cache?
No, then we don't need to cache, I guess,
Uh, is
since
it?
we will be since we have only three values to traverse from a particular position.
But still, you will have some repetitions. No, like if you go from here, 3 3 is there, so 1 is 2 2 you will take, and then 2 3 you can have, or what do you say, 2 4 you can have j plus
Mm.
1,
Then,
not 4.
then again, we will be needing this memoized GP1.
Yeah, yeah, somewhere I think we'll find repeating problem.
Otherwise, it will be, I guess, 3 to the power n.
I think in its, yeah,
Complete getting this one. Since we will having three options to take from.
yeah,
Yeah, we'll have to have three options, right? Yeah, 3 to the power n. Or else do a memoization, then it will be n square or n
and
cube.
and n
N
square
square,
only,
I
right?
guess. N square.
Yeah,
Okay. Okay.
yeah.
So at least we were able to discuss that. That's good.
We can move to next, right? Or any other.
Yeah. Let's move to the next one.
So next is like continuous subarray sum, and we are given list of non-negative numbers and an integer target. We have to write a function to check if the array has a continuous subarray of size at least 2 that sums up to a multiple of k. Okay, that is sums up to n cross k, where n is an integer. Yeah, so
Continuous sums up array. Okay.
yeah,
So when I saw this question was a little tricky. It took me a while. So basically, in simple words, what is asking us is the problem wants us to return true or false if the input array and then target. So there's two, arguments: input array and target. If it meets the following conditions, and those conditions are: if the input array has a continuous subarray with the minimum of size 2, so the subarray has to be size 2, right? And it has to be continuous subarray, and the sum of the elements of the subarray is a multiple of target. So if you look at that first example where it says 23, 2, 4, 6, 7, the target is 6, right? And the reason it's coming out true is because the second and third element, 2 and 4, is 6. So since they are continuous subarray and their sum is equal, the sum 6 is the multiple of the target. So 6, 1, 6. That's why it's true, right? So yeah, it's a little
Yeah.
tricky, but once I understood it, it was good. Yeah.
But implementing it's still tricky, right?
It
Yeah.
was tricky. There's two ways to solve it. The first is brute force approach, right? Brute force is the one that I did. The second is the one that I think Sasang is doing. We using the remainder theorem. I did not understand the remainder theorem, but the brute force is simple to follow, but it's O n square though.
Mm-hmm. Right?
Prefix sum.
It was difficult. You did a prefix somewhere? Okay.
You prefix sum and caching it in your hash map. Like, I mean, it's like we do in most of the things, right? Let's take a normal example: 1, 2, 3, 4, and you have to obtain a sum of 5, something like that. So
Hmm.
1, 3, 3 plus 3, 6, 4 plus 3, 10, right? And
Hmm.
we'll keep on caching. At this index, 0th index, we obtained a sum of 1.
Yep.
At one index, we obtain a sum of this.
Yep.
So whenever what you say, I mean, you take this and target 6 minus 6. If you do, you get 0. That means what? Between that index and your current index, definitely the sum will amount to 6.
So you're storing in a key value pairs. Is the key is the index and the value is the modulo or the sum?
Value is the prefix sum. I mean, whatever prefix sum you have obtained at this point, at 0th point, you have obtained a sum of 1. At
Hmm.
1, you have obtained a sum of 3, right? And every time you do whatever prefix sum minus target, if you find that in your hash map, that means what? Whatever sum you have obtained, I mean, to the current index,
Hmm.
and the index that you saw in your hash map, this will amount to 6. So you can get these two index. I mean,
Mm.
and then check with this condition also whether the size of this array is multiple of k or not.
Mm.
Okay. So he's not putting the index, sorry, the modulo value into the value of the hash map,
Oh,
Yeah.
right? Oh, okay. He's doing a different way.
I see. I see. I like your way. The modular theorem, I couldn't understand it. Yeah.
Modulo, what it was?
It was not a modular. It was like remainder theorem where they actually on a key value pairs they put them. Um, Key is actually your uh,
This one
mod.
you are saying sum plus k. Oh, modern. I mean,
Oh yeah,
Yeah.
he is doing the remainder thing. Yeah,
Yeah.
yeah.
Yeah. You were doing that.
yeah, yeah.
Yeah.
Okay.
Okay.
And then the k is not equal to 0, he's saying you actually just add your value, whatever you are
Well,
getting from the num.
Yeah. Yeah.
Why is that so?
Because
Because
k can't be 0. Anything divided by 0 is an error. So yeah.
error. Yeah.
but that should be a base case, correct? If k is 0, then we have to return true in that case, or no? Okay, maybe we can keep that aside. That there might be some different um, complexities in that. But if you just look at the remainder theorem,
Uh huh.
so he's trying to say, okay, do that modulo operation because the sum is a or variable which is outside the for loop. So he'll keep on adding that and keep on growing it,
Mm-hmm.
Yeah.
but he will do a modulo, so he won't allow it to go more than k,
K.
right?
Yeah.
And then he will
Remainder
just
equals to.
right. So that value you should be storing somewhere, right, in your dictionary. Oh, that you are using as a key. Okay,
Yeah. Key
and
and
then
the index, whatever I've obtained some till now. Line number
oh,
11.
okay.
Yeah.
Okay, now I get it. So what you're trying to do is whenever you get the remainder, you put that remainder at a place as a key, and
Mm-hmm.
then you store the index. So
Yep.
whenever you come back and you find the same key, okay,
Mm-hmm.
so you might surely find when you're repeating k multiple times. At that time, you're just going to take the value of that whatever the previously stored result. So you know that that's the index. In this case, in the first example, what you will do is you will take the value for, like in the case of 2, right? Or maybe 23,
Mhm.
I'm not sure where, somewhere like here. And then when you come to 4, there also the key will be the same. And then if you take this index where it is 0 and your current index is 2 in that case,
Mm-hmm.
right? So 2 minus 0, you know that you are more than 2 values apart.
Yes, you're
Yeah,
correct. Yeah.
right.
Mm.
So that is what you are returning to. Okay, then it makes
S-
sense.
So okay. So let's on that same example. So we know in the first index we store the remainder and the index, and the third is where so first 23 and 4 is where we our uh, key matches where it on the dictionary. So how does that equal? So how does that let us know that okay, well we have an array of sum of 6. That's what I'm trying to understand. Subarray of 6.
Well, the way he is doing, I think when you're doing a sort of cumulative sum, he explained, right? So he's trying to do, okay,
Line number
believe
9. Mm.
which one? This one,
The
right?
line number 9 is doing your prefix sum.
Mm-hmm.
Yeah, but here also you do the prefix sum, right? So this
Yeah,
itself is a prefix sum, correct? And then
yeah.
whenever you do a prefix sum, you also find this remainder, and that you keep on storing. So when you come to 23, now you know it is more than 6 in this case.
Yep.
So 23, the remainder should be, what should be the remainder be?
6 divided by
18,
the
5, right?
5, yeah.
So 5 is maybe 0 in this case. Then you come here. So now the value will be 5 in this case. Okay, then for the next, you will add 5 to 2. So it will be
Right.
7. 7, and in that case, you will have, if you take a module of that, it will be 1. And this also will be 1. Right? The remainder should be 1. If you do a 7 modulo 6, it will be 1 value.
Yeah.
And then when you come
Right.
to
Right.
4, so 1
Uh-huh.
plus 4 will be 5, right? So the modulo will still remain same, okay, and your value will be 2. So here also in this case, if you see, okay, you know that you found a key of 5 here, right? And this
Yeah.
index is 2. So 2 minus 0 is greater
2,
than or equal to 2. And then you
which
can
is
early exit from here saying it is true. Okay, that
I
makes sense,
see.
right?
So basically, we're saying if the modulo is same, so basically, this is the fact we're saying. If the modulo is same on our subarray, then we know that we found a subarray whose sum is equals to
okay.
divisible by 6. That's the
Yeah.
assumption.
Mm.
Okay.
We are trying, because we are doing a, prefix sum.
Mm-hmm.
So we are trying to find a place wherein the difference between those two sums, the prefix sum, is equal to our modulo k, correct?
Yeah.
Right.
So if you take a normal prefix sum, what will happen? You will have 23, okay, and then you will have 25. So this will be 25, okay, and then you will have 25 plus 4 will be 29, right?
Uh-huh.
So if I say 29 minus 23 is going to be 6, correct? So it is a multiple of k, right? So that
Yes.
is what actually the whole thing boils down, but it is slightly in a concise form.
Oh, I see. I see.
Even without modulo, we can do it. It will work. I mean, the what you are showing. But
Mm.
Really? Because then
you
how are you going to take care? Oh, okay. Uh-huh.
will put an extra check after that,
Mm.
obtaining whether it's a multiple of k. But this is more what you say, crisp and okay. Both the
Mm.
things are done in one line.
But it makes understanding more complex. Initially I was a very hard time understanding it.
Yeah.
Yeah.
True.
No, now I get it. Now the way
Yeah.
you now if we just take the modulo out, if we just look at the sum, and then I'll get it. Yeah.
Right.
And modulo, we're just simplifying our solution. Yeah.
So it looks like it's if we have to break this problem,
Mm-hmm.
if it is like just a prefix sum problem,
Mm-hmm.
we need to find a sum. Only the size should be greater than 2. That's it, right?
Right, right.
Yep.
Only now we have to come with conditions,
Mm-hmm.
and that condition here, it could be modulus and it could be different in a different situation, right?
Yeah.
And I think it so if it so the basic idea is that so if I have something like, if it's just a prefix sum, if I have a sum x, and if I'm trying to find k, so basically what I'm saying that if y minus x is equal to k, where it satisfy my condition, right?
Mm-hmm.
Okay.
So that is a basic idea of prefix sum. Like we keep on going, and if I do, so basically at any point if I do y minus k, it should come x. If I'm getting that x, that means I have that condition satisfied. And
Yeah.
Right, right. Yep. On the
Middle
same
value contributed
equation.
to K. Yeah.
yeah, and if this position is, let's say, uh, I, and this position is j, then we are saying like if j minus I is greater than equal to 2, then we have an answer.
Yes, because the
Yes.
minimum of size 2. Yep.
Mm-hmm.
Yeah, now we have to tell interviewer that how we come up with this condition, right? Now, in this case, our condition would be a little different.
Mm-hmm.
So now we are trying to say we want to do a modulus of k, right? We want to find the multiple of k.
Yes.
And
Yes.
uh, if I take if I take modulus every side, minus k modulus k is equal to k modulus k, would that work?
K modulus K will be 0.
Okay,
And yeah.
so that means you are saying y modulus k is equal to x modulus k.
Wow. Okay.
Oh, this another problem got generated out of that. Yeah.
Wow.
So basically, what I'm trying to say, at any point, I will keep on taking modulus. And when the both modulus match, that time I will try to see their positions, this condition, or whatever we discussed. That's what I think we're trying to solve here.
Right, right.
Oh,
I can give this condition also, like rather than, I think this one is will be more tougher in theoretical, like more.
wow. The way you
Yeah.
put it is so simple and elegant. I love it.
Yeah, because I spent some
Yeah.
time back, because today's modulus k, then they can say something else, divided by k or whatever.
Mm-hmm.
Like
Right.
keep on, this condition keep on changing. So I was wondering, like, to come up with, we have to also explain interviewer what's going on.
Yeah.
Mm-hmm. Yeah, makes
Mm.
sense. Because initially, the way I started, I started with what Shashank said. Okay, let's do a prefix sum. So then, when I'm doing a prefix sum, the year challenge is about the multiple of k, right? So even if
Mhm.
I store all the values, I said, okay, when I'm at this 4 index, okay, I get this 25 by 23 by just subtracting the value. Okay, but if it was multiple of k in the example 2, then it was more challenging. So do I have to do it for all the multiples of k and just keep on finding the value? Then it was more than ON's solution, right? So it was almost
Yeah.
like n square solution. So that
So,
actually tripped me off.
so what Shashank is doing, he's just putting multiple of k, and next time when he see if it is not there, he will keep on adding I, and so else means he has seen the multiple of k,
Mm.
Okay. Yeah.
and then he's trying to see the current position minus whatever he had seen last time, if it is greater than 2. But if you see, he doesn't override. The reason why he does not want to override, because he wants a maximum distance. Let's say let's say this condition was there, but it was like greater than 1 only.
Mhm.
He does not want to override, because next time if he sees something, he wants maximum distance. He does not want to override in this situation.
Oh, okay.
To get a maximum. So there is one more trick here that you only want to override something when you want to override. In this case, when the when you want maximum distance kind of thing, we need to come up with conditions like when we want to override. In this case, he didn't override because he thought like, okay, let's keep it in that way. Next time if we see the same this condition, that time I will leverage the max distance, and then definitely it will be greater than 2.
Hmm. Makes sense. Yeah.
Yeah.
Huh.
Yes, got it.
These are the small tricks, but they are very important.
Hmm.
Yeah.
Because there would be some other condition, give me a maximum distance.
Yeah.
So that question is also similar. Only you won't check this, but every time you see something similar,
Mhm.
you try to get a max
Max out of it.
I minus dictionary sum.
Mhm.
Sorry.
Yeah.
So,
Comma previous.
yeah,
Whatever
so
you have.
that time it would be max of I minus dictionary, and then we'll keep on put in some variable like m. And that time we'll say, okay, this is my maximum distance.
That will be the maximum subarray or divisible by
Maximum subarray with
by two.
multiple
Some
of k.
Yep.
And
Yeah,
if you want
that's
to find the very consecutive one, then you'll have to override in that case, right?
No, we
Last.
want the maximum distance.
No, this is fine. In that case, in if we had a problem like we don't want to find something like we have in this case we have six also, right? So if we just want to find the least subarray, so in that case we don't need to override, right? So that might be a different problem.
Hmm.
Hmm.
Yeah, then the conditions would go different.
Yeah,
That time we might not store.
yeah, and then it'll be slightly almost very different.
We might store something else here.
Mhm.
So sometimes we store index. Sometimes we store
value or something.
a value. Like it all depends how you want to compute your what is that index this pre-map
Hmm.
pre-sum map.
Yeah, but such type of problems really involve a lot of thought process, before even we start discussing with the interviewer, right?
Yeah, but so first keyword continuous or what is that contiguous.
Yeah.
So
Okay, so what is the difference there then?
uh, let me think. There is one. Okay, so there is one. There could be subarray where you can even take 1, 3, 4. It should not be continuous. It is what is that subsequence? Sorry.
Okay, the subsequence and okay,
Yeah,
Subarray.
subarray. Okay, yeah, yeah.
yeah. First continuous or contiguous or subsequence. That is the first check.
Mhm.
If it is a continuous, then there could be option we could able to use a pre-map thing, but not sure. Like we need to ask more questions to the interviewer, like what exactly the interviewer is looking for. But if it is a subsequence, then I don't think so. We can use a pre-sum or
Yeah,
might
but for a different problem, right? Okay.
because then it is not together like 1, 3,
Yeah,
4.
it has to be next to each other. Yeah.
Yeah. So if it is a continuous or contiguous, then I always start with this visualizing that if you have some condition like k,
Mhm.
if I just have to simply see a sum, then this is y when we do a pre-sum, this is x, and y minus k is equal to x, that is my answer. Then can I play with the other factors which now interviewer has given me
Mm.
and see if I can come up with some condition. If this condition is derived, then I think is the easy part.
Yeah. Okay, y minus k equals x, and then you do modulo for all. Hmm.
If this
I
condition is derived, then we have to just see what we have to do with this I, whether we want to overwrite it or we don't want to overwrite it.
Hmm. Yeah.
many questions can be made on this general pattern. Like we can Shall I share my screen?
Yeah,
I'll start
please.
in question.
Let me stop it. Go ahead.
Like this is find pair with given sum in the array. So this is same, but we don't need to modularize it. Like when we were doing a mod k, we don't need to do mod k in this problem. Find pair with given sum in the array. So we will start from one index. Uh, like we will start from 23 and we will keep adding the prefix. And uh, if at any index we will check the prefix minus the given sum value exists in the map, then we know that this contiguous subarray will have sum with the given value.
But was that a contiguous one? Find the pair.
Uh, okay, no. If we change this question to find contiguous subarray with given sum,
Okay, okay, okay.
That is hash map question first one here.
uh, uh,
Okay.
then check if subarray with zero sum is exist or not. Same question. Since subarray is given, the elements will be contiguous. So
Hmm.
at any point, if the prefix sum which we got at that index and that same prefix sum we got at any previous index, then we know that the sum between these two index will be zero.
It will have both negative and positive numbers in the array, right?
Yes, yes, yes. It should have negative, then only it will be zero.
No, only
So
zero.
same
Array filled with zero.
for zero also it will be. Then this print all subarrays with zero sum. So here we need to use multi-map. Since we need to store
Slightly.
all the index we have to use. We don't need a particular index. We will be needing all the index of the prefix which we used. Then find maximum length subarray having given sum. It was discussed just now. Then find maximum length subarray having equal number of zeros and minus one, and zero and one. So in this question, what we can do is we can replace the zero with minus one, and when we do the prefix sum, uh, minus
Zero.
one, minus one plus one will be zero. Then we just need to check. This question will become this again. Check if
Yeah.
a subarray with zero sum is exist or not. So this is a this can be used as a general pattern for many problems.
Yeah. So Abhishek, can you ping this link so other people can
Yeah,
also?
yeah.
Yeah, this is interesting. Yeah. Are these all lead code problems or some other?
I
I
think these
think
are lead
most
code
of the
only.
Oh,
most of the problems can be found on Leetcode.
Leetcode, yeah.
okay.
Yeah,
But
I think most of them are a Leetcode, but if
yes,
not,
yes.
then it would
General
Geeks.
interview
Geeks.
questions.
Geek.
Yeah.
What is that? Geek for geek might be.
Yeah. That is the question.
Mm.
You can post in the lead code Discord only so that the message will
Yes,
remain for long.
yes,
Yeah.
yes, yes. Just we need to use the map or multi-map in optimized way. Otherwise,
Oh,
the brute force way will be big of n square, where we'll be iterating all the subarrays and taking the sum or modular sum.
what is this 13 line? 13.
Shuffle a given
Shuffle.
array of elements.
Shuffle. Can you just click on that?
So that is the problem you don't know, Shashank.
Oh,
That's the only problem you don't know out of this.
yeah. Almost like
Given an array of.
That was a good one.
Okay, we need to randomly shuffle an array.
Uh,
uh, that's a standard theorem or your preset yet shuffle is
I
used to
think
generate
this is
the
a
random.
Fisher-Yates shuffle. Is a standard topic, I guess.
Yeah, looks like.
but they are
Hmm.
generating some permutations, right? Yeah.
But it is taking a random one, at,
Hmm.
and then it is swapping, so it is a random shuffle.
Wow, that's very different.
Yeah, it's like
This uses even in some of the music players. Sister Yada shuffle.
Hey, Uday, I'm unable to hear you very clearly. Can you be a bit louder?
They just use it. This 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 one is used in music players as well. Shuffle
Music?
songs. This
Yes, yes,
exact
yes, yes.
Sister Yada shuffle.
When we click the shuffle button, it generates a random playlist of the playlist which we selected.
in YouTube
In,
also. Yeah.
yes, yes, yes.
Oh,
On
okay.
all
I'm
the
not
music.
sure about YouTube, but at least in music player it is there. I mean, this
Yes, in
exact.
Spotify it's there. In YouTube Music also it is there.
YouTube Music is there, and nowadays I think Netflix also has something like let's watch something. So probably that also is shuffle.
Randomized
I
But
think
video.
Yeah,
Netflix
one
uses
item from
uh,
shuffle. Maybe
Netflix uses
I'm
a
not sure.
recommendation engine for
Yeah,
suggesting.
that's a ML
Okay.
algorithm recommendation engine we use for
Yes,
that.
Yeah.
Whatever
Netflix
things you see,
Netflix
similar
uses
things.
Okay.
Netflix uses a recommendation engine.
Even YouTube uses recommendation engine. Whatever history based on that only it will show you things, right?
Yes, yes, yes.
Yeah,
even
but
in
then it is
Spot,
relevant at least for the playlist, right? Yeah, that is good.
Exactly. Yeah.
Mm-hmm.
but I mean, Spotify has a good article on this one. How we shuffle the songs. So people complained they didn't like the shuffle service or something like that. So they tried to find what is they actually first implemented the Frister as a shuffle itself, and then they find that true randomization might not be real randomization. I mean, as per human how humans think.
Mm-hmm.
So they
Oh,
they try to group songs via I mean, so when you shuffle the song, it might be possible that songs by different singer can be placed simultaneously, right? But you may not want that in a shuffle service, right? So Spotify has a good blog on how they encountered this problem from the users and how they improved the shuffle. So they tried to group the songs on various criteria like singers and what type of song it is, like pop or different one, and shuffle on different sort of that criteria.